started to develop two different thoughts to plant community change over time. One was that, oh, the plant communities that you see right now that are stable, is somewhat stable. They're resistant to being invaded by any one organism taking it over. It's a stable state. They may have started with this initial floristic composition, that what you start with at the beginning, you plant all the stuff at the beginning and you turn it loose, and then through time the plant communities will change and turn into something else. That's the initial floristic composition. Well, then there's another approach that was discovered during mostly during grassland establishment for prairie grassland, is that if you set everything up, you plant everything up at the beginning and you walk away and let it just run, there would be species that dropped out. But if you introduce those species later on in system development, they'd actually get a toehold and grow and develop. So it started to be learned that plant communities also change through time by additional inputs of seed or seedlings or roots and whatnot, and that became known as the relay floristics model. So the two different things, the relay floristics and initial floristic composition, they kind of operate differently internally within them. If you set up a system all at once, all by itself, and there are no new inputs of species to that system, most of the effects that change the populations have to do with competitiveness. It may be speed of growth, or how quickly, how precocious the plants are, how fast they go to seed, total amount of seed, so how much they yield, how much they bear. It could be how well they utilize nutrients or water, etc. So competitive effects are more observed within a model that's kind of following initial floristic composition. And then the relay floristics involves new inputs of seed and or spores or propagules from the outside. The change in a system that's following the initial floristic composition model, the changes that happen within there are oftentimes more rapid than through the relay floristics model. And part of what this curve shows here is, there's a lot of different things that follow this set of curves here, but this talks a little bit about system stress. If we've got the abiotic parts of the system, the non-living, the water, the soil, mineral composition, etc., that's all the abiotic, non-biotic stuff. If something is really uninhabitable, hardly any plants are growing there. So let's pretend that we're starting on a site that's really uninhabitable. Stress is high. Well, over time, succession takes place. Early succession, primary succession. We've shown models of the rock going to lichens, going to mosses, going to grasses, going to thorny bushes, going to sun-loving plants. Well, what happens over time is now the abiotic stresses kind of go down, because the lack of soil nutrients that is obvious on a rock, there's not a lot of soil there, those minerals now become bioavailable. They're part of the system, so this abiotic stress goes down. As the plants start to produce the beginnings of soil, their ability to hold moisture goes up. So the stress level goes down, abiotic stress level goes up, and the number of species and the health of the species actually go up. And so what happens in early succession, there's not a lot of competition between the different plants that are in that population, because there's room for everybody. The site hasn't been completely fully colonized yet. Well, at a certain point in time, now there starts to be more competitive stress between organisms in that system, till we get to this state right here where we have like a maximum diversity of species, possibly a maximum energetic cycling of energy and nutrients and water. The abiotic